Today we're going to learn about the standard form of a quadratic equation and how to find the key features given an equation in standard form. So the standard form is y or f of x equals ax squared plus bx plus c. You can see two examples given here. F of x equals 2x squared plus 4x minus 1, and y equals negative x squared minus 2x plus 5. We're going to find the key features of the graph, including the vertex, axis of symmetry, y-intercept, and whether the graph has a minimum or maximum, all from this given equation. So if you remember, the a value, or the number in front of the x squared term, determines the opening and the direction of your graph. So if your a value is greater than 0, which means it's a positive number, that means your graph is going to open up. Like that. That means your vertex is a minimum. If your a value is less than 0 or a negative value, that means your graph is going to open down, giving your vertex a maximum. B we're going to use to help find our vertex and axis of symmetry, but it doesn't give us anything directly. C represents the y-intercept of the graph, which can be found at the point 0, c. So given the equation f of x equals 2x squared plus 4x minus 1, it's good to label what a, b, and c are first before you use them to find the key features. So a would be 2, b is positive 4, c negative 1. Now we can automatically find our y-intercept from the c value. So our y-intercept is going to be at the point 0, negative 1. Our a value determines which way the graph opens. So since our a value is a positive 2, that means it's greater than 0. So our graph is going to open up, which means our vertex is going to be a minimum. Our graph is going to open up. So that means our vertex is the lowest point of our graph. And now we can go ahead and find that in our axis of symmetry. If you remember, the axis of symmetry is the line that divides the graph in half, the vertical line that passes through the vertex. You can find the axis of symmetry by the equation x equals the opposite of b divided by 2a. Now we already know our b value is positive 4. So the opposite of positive 4 would be a negative 4 divided by 2 times our a value, and our a value is 2. And we can simplify that. So negative 4 divided by 2 times 2 would give us negative 4 divided by 4, since 2 times 2 is 4. And negative 4 divided by 4 would give us an x value of negative 1, which means the equation of the axis of symmetry is x equals negative 1. And if you remember, a vertex is an ordered pair or a point, which means we need the x and the y value. We already know the x value is at negative 1. What we need to find is the y value. We can substitute the point or the value that we got for our axis of symmetry back into the equation everywhere you see an x. And we're going to use that to find our y value or value at our vertex. So f of negative 1, everywhere you see an x, you replace it with a negative 1. So 2 times negative 1 squared plus 4 times negative 1 minus 1. And we're going to simplify that. Negative 1 squared is a positive 1. So 2 times positive 1. 4 times negative 1 is negative 4 minus 1. 2 times 1, 2 minus 4 minus 1. Remember, left to right, so 2 minus 4 is going to give us negative 2 minus 1. Simplifies to negative 3. That means our vertex is at the point negative 1, negative 3. Now we have found our y-intercept, our vertex at negative 1, negative 3, which is a minimum, and our equation of the axis of symmetry from the given standard form equation, which means we have enough information to create that graph, which you'll see in lesson 2. So let's go ahead and try it with this equation. Y equals negative x squared minus 2x plus 5. So we want to label our a, b, and c values. A is represented by this negative here. So a is equal to negative 1. B is equal to negative 2. Don't want to forget the sign that comes before it. And C equals positive 5. So remember, we can automatically find our y-intercept by the value of c. So it would be at the point 0, 5, since c was equal to 5. We can also find whether this graph has a minimum or maximum by our a value. In this case, our a value is a -1, which means it's less than 0. So our graph would open down. Our graph would look like that. So that means our vertex is a maximum. It's going to be the highest point of the graph. Let's go ahead and find our axis of symmetry using the equation x equals the opposite of b divided by 2a. So the opposite of b, now b is already a -2. So the opposite of -2 divided by 2 times a, which is -1. Opposite of a negative is a positive, so x equals +2 divided by 2 times -1, which is -2. 2 divided by -2 is going to result in a -1. So the equation of the axis of symmetry is x equals -1. That's just a coincidence from the first problem. And now we can go ahead and complete our vertex. We know that the x is -1, and we need to find the y value. So we can substitute this x value in the place of every x in the equation. So y equals instead of x, we're going to replace it with a -1 squared minus 2 times -1 plus 5. So -1 squared is a +1, times a -1 makes it a -1. -2 times -1, +2, plus 5. -1 plus 2 is going to give us a +1 plus 5, gives us a y value of 6, which means our ordered pair for our vertex is at -1, 6. So we were able to find the y-intercept, the vertex, the axis of symmetry, and the direction of the graph, whether it has a minimum or maximum, from the given standard form equation.